The next presenter is Ahmed Abdelaziz from eAdmet. They are the provider of OCHEM, which is a platform for building ADMET prediction solutions.
Thank you, Nora. So again, the tough challenge to finish within 5 minutes. What's more important than giving a new feature is actually to make sure that you all know what we are doing. So quick introduction, we are a company that is based in Garching now. This is our new premises and this is the team. And we are the same team behind ALOC-PS and the VCC lab. And now the new platform, which is very comprehensive for QSAR, for building QSAR models for ADME prediction and other physical-chemical properties, is called the OCHEM. We are established since 3 years now, and we were originally a spin-off from the Helmholtz Center in North Munich. So the area we are working in is the lead identification and optimization. So it's the phase of early discovery. And the main platform that we have is called OCHEM platform. It's not the only platform, but it is the main product. And it facilitates the process of QSAR building. So it takes the whole process from its integrated database or connected to the internal database of a company by NIME or pipeline pilot, and takes that through the machine learning algorithms and the descriptor packages calculation and the parameter selection up to the estimation of applicability domain and then interpretation of the models using scaffolds and other features. So the feature, the new feature that I'm going to present quickly to you today is called set compare. And the idea behind it is that you would be able to get a better interpretation of a model that you have built. So let's say that you built a model using OCHEM, for example, using a nonlinear method, so for example a neural network, and you cannot really decipher what's the intern, what is the reasons behind that. So such a feature would allow you to better understand your model. And basically, this feature would calculate a p-value based on a hypergeometric distribution for the two sets of compounds. So if you have, for example, a set of active and inactive compounds against a certain receptor, it would analyze it using scaffolds and calculate a p-value for the scaffolds that are most present in one of the two sets. And the available scaffolds so far are the ChemAxon scaffolds, scaffold from Scaffold Hunter and Silico IT scaffolds. And you can basically use any set of descriptors. We have more than 20 descriptor packages that can be that are already integrated with the OCHEM, and you can use any of them. You can use fragmental descriptors, for example, also to see which fragments are more present in one of the sets of your compounds. So in action, if you want to visit OCHEM, it's available for non-commercial use, completely free on ochem.eu. And if you are interested in if you have a set of compounds that are private data and you want to test it, you just write me an email, and I would be outside in one of the tables, and we can ship you a complete standalone version where you can put your compounds in it. This is how the public platform looks like. It's completely free, as I said. If you go under models here and then compare utility, set compare utility, you would then select your two sets. So you can upload them from an SDF file, or if you have already been working with the system, you can include your previously prepared sets using our system. And go ahead directly. This is a snapshot of the descriptor packages. So not all of them would be basically suitable for such an exercise, but just for you to know, we have, for example, the ChemAxon calculators, all of them, Dragon descriptors, Izida, and many other, the E-states, of course, shape signature, so many other descriptor packages. And I would select for this the ChemAxon scaffolds, and then you just basically click next. It would start calculating. You can shut down the computer, have a coffee, because it's completely web-based, so it would run on the background. We have currently an implementation with 600 CPUs, so it would finish within probably 3-4 minutes. Then when you come back, it would turn into green. So every record of these are actually one calculation task. So once your task turns into green, you can analyze the results. And for this, I have quickly selected 2 sets of AMES compounds. You can check the publication, and it would show you directly what are the scaffolds that are more associated with compounds that are mutagenic, and you can immediately recognize scaffolds that have been reported already really in literature as mutagenic groups. Just before I leave, this is the new released models. Since last year, you would recognize solubility in DMSO, the melting point, for example, aryl hydrocarbon receptor activation. There are a lot of other models that we have released, and most of them we have publications for already. And please feel free to check them online or get in touch with me if you need more information. This is our partners, and ChemAxon is always in the heart of them. And I would like to thank you at the end, and you can meet us outside. Thanks.